In the name of Allah, who is the most beneficent and most merciful. My name is Arij Fatma from Department of BS Chemistry. My ID is 001 and this is the presentation of Environmental Chemistry. Today I am going to present two topics. First is hydrologic cycle and second is unique properties of water. Here are the contents. In the first part, hydrologic cycle, we will discuss about its process, and in the second part, which is unique properties of water, in which we discuss water molecule and hydrogen bonding, boiling and melting point, heat capacity, alkalinity, acid-base properties, and temperature density relationship. So, what is hydrologic cycle? Hydrologic cycle is also called water cycle is describes the continuous movement of water on, above, and below the surface of Earth. It also describes exchanges of water between oceans, atmosphere, land surfaces, biosphere, soils, groundwater systems, and the solid Earth. The Earth's supply of water is continually being purified and recycled in the hydrologic cycle. So here are the process which involves in hydrologic cycle: evaporation, condensation, sublimation, precipitation, transpiration, runoff, and infiltration. So the first process is evaporation. The water cycle starts with evaporation. It is a process where water at the surface turns into water vapors. Water absorbs heat energy from sun and turns into vapors. Water bodies like oceans, seas, the lakes and the river bodies are the main source of evaporation. Through evaporation, water moves from hydrosphere to atmosphere. As water evaporates, it reduces the temperature of the bodies. So, what is condensation? As water vaporizes into water vapors, it rises up in atmosphere. At high altitudes, the water vapors changes into very tiny particles of ice or droplets because the temperature at high altitude is low. This process is called condensation. These particles come close together and forms clouds and fogs in the sky. So, what is sublimation? Apart from evaporation, sublimation also contributes to water vapors in air. Sublimation is a process where ice is directly converts into water vapors without converting into liquid water. This phenomena accelerates when temperature is low and the pressure is high. Sublimation is rather a slower process than evaporation process. The next process is precipitation. Prevailing winds carry moist air and clouds across the surface of Earth. If the moist air cools sufficiently, water droplets or ice crystals fall to the ground as precipitation. Precipitation that falls through clean air is pure and contains only gases that are dissolved from atmosphere and traces of dissolved salts. Although some of this precipitation becomes locked in the glaciers, most of it either sinks into the soil or flows downhill as runoff into nearby streams and lakes, eventually making its way through rivers and wetlands to oceans. So the next process is transpiration. As water precipitates, some of it is absorbed by soil. This water enters in process of transpiration. Transpiration is a process where liquid water is turned into water vapors by plants. So the roots of plants absorb the water and push it towards leaves where it is used for photosynthesis. The extra water is moved out of the leaves through stomata as water vapors. Thus, water enters the biosphere and exits into gaseous phase. So the next process is runoff. As water pours down, it leads to runoff. Runoff is a process where water runs over the surface of earth. When snow melts into water, it leads to runoff. As water runs over the ground, it displaces the topsoil with it and moves the minerals along with the stream. This runoff combines to form channels and then rivers and ends up into lakes, seas, and oceans. So the last process is infiltration. Some of the water it precipitates does not run off into the rivers and is absorbed by plants or gets evaporated. It moves deep in the soil. This process is called infiltration. The water seeps down and increases the level of groundwater, which is called pure water and is drinkable. The infiltration is measured as inches of water soaked by the soil per hour. So this is the cycle of hydrologic cycle. Uh, in this transpiration is the process of water movement through a plant and its evaporation from aerial parts such as leaves, stems, and flowers. Water is necessary for plants, but only a small amount of water taken up by the roots is used for growth and metabolism. The remaining 97 to 99.5% is lost by transpiration and guttation. And the next process is evaporation. Evaporation is a type of vaporization that occurs on the surface of liquid as it changes into gas phase. The surrounding gas must not be saturated with evaporating substances. When the molecules of liquid collide, they transfer energy to each other based on how they collide with each other. So, the next process is infiltration. Infiltration is the process by which water on the ground surface enters the soil. It is commonly used in both hydrology and soil sciences. The infiltration capacity is defined as the maximum rate of infiltration. Let's move towards the next process, which is percolation. Percolation is the process of a liquid slowly passing through a filter, then move towards the process which is called surface runoff. Surface runoff, also known as overland flow, is the flow of water occurring on the ground surface when excess rainwater, storm water, meltwater, or other sources can no longer sufficiently rapidly infiltrate the soil. Next, move towards the water table. Water table is an underground boundary between the soil surface and the area where groundwater saturates spaces between sediments and cracks in rock. Water pressure and atmospheric pressure are equal at this boundary. Then move towards aquifer. Aquifer is a body of rock or sediment that hold groundwater. Aquifer basically is of two types: confined aquifers and unconfined aquifers. Confined aquifers have a layer of impenetrable rock or clay above them, but unconfined aquifers lie below a permeable layer of soil. Then the next process is evaporation. Evaporation is the type of vaporization that occurs on the surface of liquid as it changes into gaseous phase. And the last process is precipitation. Precipitation is water released from clouds in the form of rain, freezing rain, sleet, snow, or hail. It is the primary connection in the water cycle that provides for delivery of atmospheric water to earth. Most precipitation falls as rain, and condensation is a process in which cloud formation occurs. This is the whole hydrologic cycle in which these processes occurs. So, what are the unique properties of water? Water is the only common pure compound on earth that is a liquid. It is also possesses many unusual, even unique properties. If water behaved like other chemical compounds of similar molecular weight and structure, life on earth could not exist. Most of water's extraordinary properties are the result of hydrogen bonding, which is associated with this molecule. Although hydrogen bonds are much weaker than ionic or covalent bonds, they have a profound effect on the physical properties of water in both its liquid and solid states. First, we talk about the first unique properties of the water, which is water molecule and hydrogen bonding. A water molecule can form four hydrogen bonds. The oxygen atom in the molecule can bound um, to two hydrogen atoms in other molecules because it has two pairs of unshared electrons. In addition, each hydrogen atom in a water molecule can bond to an oxygen atom in another molecule. These bonds are directional, which means that they can form only when the molecules are correctly oriented relative to each other. And this is the diagram in the in A figure, hydrogen bonding in water. In a figure, water is an angular polar molecule. Because oxygen is more electronegative than hydrogen, it has a partial negative charge, and the two hydrogen atoms have partial positive charge. And in the B figure, the slightly negatively charged oxygen atoms are attracted to slightly positively charged hydrogen atoms, and hydrogen bonds form between adjacent water molecules. Each oxygen atom has two pairs of unshared electrons and can bond to two hydrogen atoms. In liquid state, water molecules are in constant motion and hydrogen bonds are continually being formed and broken. The arrangement of molecules is random and not all processed hydrogen bonds are formed. But in the liquid state, but in the solid state, which is ice, molecular motion is at a minimum and molecules becomes oriented so that the maximum number of hydrogen bonds is formed. The second unique property is boiling point and melting point. Compared with the hydrogen compounds of other elements in group 16, 6A of the periodic table, water has an unexpectedly high boiling point. Normally, boiling point in a series of compounds of elements in the same group increases regularly with increasing molecular weight. This occurs for H2S, H2SC, and H2TE. The hydrogen bonding that water molecules engage in causes the unexpectedly high boiling point of water. The molecules of other hydrogen compounds in group 6A elements do not hydrogen bond to any significant extent. When water is converted to vapor, additional energy in the form of heat is required to break the hydrogen bonds. Consequently, water's boiling point is higher than would be expected. If water boiled at predicted temperature of minus 80 degrees Celsius, it would be a gas at temperature found on Earth, and life as we know it would not be possible at that temperature. Water also has an exceptionally high melting point because of the large quantities of heat energy which is required to break its hydrogen bonds. When ice melts, approximately 15% of its hydrogen bonds are broken. The three-dimensional lattice structure collapses and water forms. With the exception of oxygen, the boiling point of hydrogen compound of group 6A elements increases regularly going when we go down the group. The unexpectedly high boiling point of water is the result of hydrogen bonding, which occurs in water but not to any extent in other molecules. The third property is heat capacity. Heat capacity is the quantity of heat that is required to raise the temperature of given mass of substance by 1 degree Celsius. It takes 1 calorie of heat to raise the temperature of 1 gram of liquid water by 1 degree Celsius temperature. Water has the highest heat capacity for any common liquid or solid. From definition of heat capacity, it follows that the higher the heat capacity of substance, the less its temperature will rise when it absorbs a given amount of heat. Conversely, we can say that the less its temperature will fall when the same amount of heat is released from it. What is the heat capacity of a substance? Heat capacity of the substance can be expressed as the ratio Q by T, where Q is the total heat flow into or out of an object, and T is the temperature change produced. And is the and it is the quantity of heat that is required to raise the temperature of given mass of substance. The heat flows equal the heat capacity times the temperature change. The heat capacity for 1 gram of substance is called the specific heat, and the unit for specific heat are joules per gram. The high specific heat of water helps our body maintain its constant temperature of 37 degrees Celsius much more easily. A human's body is approximately 70% water, and because of its high heat capacity, the body can release or absorb considerable amount of energy with little effect on body temperature. The high heat capacity of water has enormous implications for the Earth's climate. The oceans, for example, can absorb very large amount of heat without showing a corresponding rise in temperature. They absorb heat from the sun on warm days, primarily in summer, and release it in the winter. If no liquid water to absorb and release heat, temperature on the earth would fluctuate as drastically as they do on the waterless moon and planet Mercury, varying by hundreds of degrees during each light, which is cycle. Here, here are the specific capacities of some pure substances. Water has a specific heat of 4.184 in liquid state, and water has the specific heat capacity of 2.03 in solid state. Aluminium, which is in solid state, has 0.89, carbon 0.71, iron 0.45, and calcium carbonate in the solid state 0.85. So the next property is alkalinity. Alkalinity is the capacity of water to accept hydrogen ions to reach a pH of 4.5, which is the second equivalence point in titration of carbonate with hydrogen ions. Generally, alkalinity is controlled by concentration of hydroxyl ions, carbonates ions, and bicarbonate ions in water. Because these ions can act as pH buffers and as a reservoir for inorganic carbon, the determination of alkalinity of natural water is a measure of its ability to support aquatic life. Here, alkalinity is controlled by concentration of hydroxyl ions plus 2 moles of carbonate ions and 1 mole of bicarbonate ions. When water sample that has a pH of greater than 4.5 is titrated with acid to a pH 4.5 endpoint, all hydroxyl ions, carbonate, and bicarbonate ions will be neutralized at that point. The endpoint of pH 4.5 can be measured using a pH meter with hydrogen ion sensitive glass electrode. Alkalinity is usually expressed as millimoles of hydrogen ions, which is needed to bring 1 liter of water to pH 4.5, which is the endpoint. Natural waters typically have an alkalinity of 1 millimole. The individual contributions made by bicarbonates, carbonates, and hydroxyl ions depend on the pH of water. So the next property is acid-base properties. Water undergoes self-ionization, which is called autoprotolysis, in which it acts as both an acid and a base. And these are the reactions in which water also act as an acid and also act as a base. Water is a protic solvent because it can give up hydrogen ions. Dimethyl ether, in contrast, is an example of an aprotic solvent which has no acidic protons. The autoprotolysis constant for water has the special symbol Kw, where the W indicates the constant is for water. And this is the reaction when water reacts with water and forms uh, hydronium ions plus hydroxyl ions, and Kw is equal to concentration of hydrogen ions plus and hydroxyl ions, and the Kw for this reaction is 1.0 into 10 raised by minus 14, uh, which is obtained at 1.1 into 10, which is obtained at 25 degrees Celsius temperature. Kw is temperature dependent constant and has a value of 1 to 10 raised by minus 14, which is obtained at 25 degrees Celsius. Acid-base actions in water involve the loss or gain of hydrogen ions by water. Many species act as acids in water by releasing hydrogen ions, whereas other act as bases by accepting hydrogen ions. Water can act as either both an acid or an base. So, the temperature density relationship. What is density? Density is defined as mass per unit volume. The density of most liquids increases with decreasing temperature and reaches a maximum at freezing point, but the density of water does not. When water is cooled, its density reaches a maximum at 4 degrees Celsius to 4 degrees above the freezing point and then decreases until the freezing point is reached at 0 degrees Celsius. The fortunate consequence of this property is that ice floats on the surface of water. This behavior is so familiar that we tend to forget that it is not typical of most liquids. For example, if a piece of solid paraffin is put into the container of liquid paraffin, it sinks to bottom of container because it is denser than liquid. The unusual behavior of ice is the result of open lattice structure of hydrogen bonded molecules that forms when water freezes. The molecules of water are farther apart in ice than in liquid water. As a result, when water starts to freeze, the number of molecules per unit volume decreases. Because of the density of water, lakes develop a seasonal pattern. During the summer, lakes develop a three-layer profile. As we can see in this figure, epilenium la- ep- epilenium layer is near the surface, and the metallium layer is the middle layer, and the hypolimnium layer is the bottom layer. Photosynthesis takes place in epilenium layer as solar radiation penetrates it, which stimulates algae to produce oxygen. The hypolimnium layer, by comparison, is relatively dark but rich in nutrients. Decomposition of organic matter at bottom of the lake consumes oxygen and depletes the dissolved oxygen in hypolimnium layer. When the warm season ends and cooling occurs, surface water becomes denser than the hypolimnium, causing the surface water to sink, carrying with it dissolved oxygen. The deep water hypolimnium layer then rises. This mixing process, which is called overturn, causes an increase in chemical and microbiological activity of the lake. Water in the epilemium which has a large quantity of dissolved oxygen, drops oxygen to the creatures living deep in the lake. Conversely, water in the hypolimnium, in which the oxygen has been depleted, rises to aplimnium, where it can come in contact with atmospheric oxygen gas at the surface and start to replenish its supply of dissolved oxygen. The changes in the temperature of air over a lake causes the layers of the lake to mix in a process which is called overturn. As a result, Ice is less dense than water has important consequence for aquatic life. When air temperature falls below freezing in winter, water at the surface of lake and ponds begin to freeze and a layer of ice forms and floats on the water below it. The ice covering the surface acts as an insulating layer, reducing heat loss from water under it. Most lakes and large ponds in temperature climates never freeze to a depth of more than a few feet, and fish and other aquatic organisms are able to survive in winter in water under the ice. If water behaved like most other liquids, ice would sink to bottom as it formed, and lakes and ponds would freeze from bottom up. Even deep lakes would freeze solid in winter, and aquatic life would be killed. The water's unusual behavior is when freezing has other consequences for environment. When water trapped in cracks in rock freezes, it expands, and the force of expansion is so powerful that the rock may split, which is an important factor in its weathering. That's all from my side. Thank you.